Welcome back. In this video, we are going to check out exception handling, which means the handling of runtime problems which occur in the program and would otherwise lead to program termination. So this is the case for not only apps, but for all programs. So what is an exception? An exception is a runtime problem which occurs in the program and leads to program termination, which on the phone means that the app is not going to respond. Now, that is a very, very bad behavior. So you should at all costs try to avoid exceptions to not be handled. So to just run. So examples would be running out of memory, array out of bound, condition like divide by 0. And to handle this type of problem during program execution, the technique of exception handling is used. And exception handling is a technique which handles the runtime problems and maintains the flow of the program execution. So when you use exception handling, the exceptions may still arise, but they will not make your program crash and your program will still work, even though it might not do the things as intended. For example, if you try to access the internet and you don't handle the exception that the internet connection doesn't work, then you would run into an error. So you would get an exception because you can't connect to the internet. And that could break your app if you don't handle this exception. That's why it's super important to handle those kind of exceptions and still make your program work. So even if the internet doesn't work, then you will just display something to the user, please turn on your internet or get an internet connection or something like that. All right, so there is the throwable class, which allows us to throw an exception. So this throws an exception if we use this throw keyword and then the name of the exception. I called this exception my exception because we can create our own types of exceptions, which will then do whatever we want to do in those cases. There are 4 different keywords used in exception handling, and these are try, catch, finally, and throw. So these are the main keywords, and we're going to check those keywords out. So keywords used in exception handling, let's look at the try keyword. The try block contains a set of statements which might generate an exception. It must be followed by either catch or finally or both. All right, so this is the code that can break, that can make or create an error, create an exception, such as connecting to the internet or running through an array. So there can be a lot of issues that come up. Then the catch block is used to catch the exception thrown from the try block. So if there is an exception in the try block, the catch block should execute. Otherwise, it will not execute. So if there's no problem in the try block, so if the code works perfectly fine, for example, back to our internet problem, let's say we have internet and we try to exit the connection, then we will not have a problem. The try block will work. The catch block will not execute. But if the internet connection is not there, then of course the catch block should run. Then we have finally. The finally block allows execution whether exception is handled or not. So it's used to execute important code statements like closing buffers. For example, closing a buffer which takes care of the connection to the internet, or a buffer that takes care of storing data on the phone. So these are things that need to be closed after they have been opened, and that is usually done in finally. So after the try block has been executed or after the catch block has executed if there was an error. And then we have this throw keyword, which allows us to throw an exception explicitly. So we ourselves write this in order to throw an exception, in order to cause an error. And this is especially useful when testing to see where an error occurs, and we create our own exceptions or throws so that we know, okay, this is something that we just wrote. All right, and then there you are sitting in front of your code and suddenly an exception arises. Well, the thing is that usually happens when you have unchecked exceptions. So an unchecked exception is the exception which is thrown due to mistakes in our code. So our code for some reason doesn't work, and there are multiple different exceptions, and the exceptions then run during runtime or execute during runtime are runtime exceptions, and they extend from this runtime exception class. And the unchecked exception is checked at runtime, which means when our app is running, and not during compile time, meaning when we compile our app and press, for example, the run button. Examples of unchecked exceptions are arithmetic exceptions thrown when we divide a number by 0, for example. Then the array index out of bound exception is thrown when an array has been tried to access with incorrect index value. So let's say the array only has 5 values, but you're trying to access the 6th or 7th value, then you get this error. You can very easily try that and force this kind of an error, and you probably have seen this already. And then the security exception thrown by the security manager to indicate that we have a security violation. So for example, we're trying to access GPS, but we don't have the rights to access GPS because the user didn't give us the rights to use the GPS functionality. And then the very common null pointer exception thrown when invoking a method or property on a null object. So when we try to access an object which is empty, which is null, then we get this null pointer exception. And that is something that I have already talked about when we looked at nullables. Then checked exceptions. Well, they are exceptions which are checked at compile time. So pretty much in our code, we write this ourselves. This exception type extends the throwable class. So there's a class called throwable, which takes care of the exception functionality. And examples of checked exceptions would be the input-output exception, so IO exception, or the SQL exception, and there are a bunch more. Now let's look at the try-catch block, which is used for exception handling in the code. The syntax of try with catch block looks like this. So we have this try, then code that may throw the exception, and then we have this catch, for example, some exception. So this could be the IO exception if it's an input-output exception, or it could be just a generic exception. So we would just use the generic exception class name here. And then we have our code that handles the exception. And of course, we need to close the bracket here. All right, examples without exception handling. So in this case, we have an exception handling written ourselves, so try and catch, but the exception is never arising because the problem doesn't appear. So here, for example, we use value string get number. So we use this function get number, and we have a value of 10 there. So the variable string is getting the int value of 10 and then making a string out of it. So we're trying to integer parse int. So we're trying to parse that value into a string. So it's an integer, right? 10, but we're making a string out of it. And if something goes wrong, for example, an arithmetic exception appears, then we want to output 0. All right, so if we run println string now, we get the output of 10. All right, now let's look at the exception handling when it's actually running. So when we actually do have an exception handling running, and that is the case, for example, if we try to have a parsing here with a value of 10.5. So in this case, we're trying to parse a double as an integer, and that doesn't work. So we have to be careful with the type here, of course, and that creates an error. So our try block does actually create an arithmetic exception. So the output is 0. So whatever we have in our catch block here. All right. So that is something that we, of course, have to be careful with. Then we can have multiple catch blocks. So we can use multiple catch blocks in our code, and they are used when we can have different types of operations or different types of operation errors in a try block, which may cause different exceptions in the try block. So here an example, we have this function where we try to get the value a out of an int array, which is 5, so which has 5 elements in there. And now we're saying a at position 5, or at index 5, which means at its 6th position, should be 10 divided by 0. So there are a bunch of problems that we create here. One of them being that 10 cannot be, or anything cannot be divided by 0. So we get an arithmetic exception here, trying to divide by 0. Not good, doesn't work, creates an error. And then we're trying to access an array at a position which doesn't exist. So the array just has 5 values, but we're trying to access its 6th value. So we're creating this problem here. So here, this is where the problem arises. All right. So we have 2 errors that can appear here. And then we have the arithmetic exception, which takes care of arithmetics, or then we'll just print arithmetic exception catch. So for example, trying to divide by 0. Then we have an array index out of bounds exception, which will be run because of this a accessing index 5. And then we have a generic exception, which is the parent exception class. So it's just the name exception. So you can see in catch, we always have this e colon and then the name of the exception that we want to use. And by the way, you can get information about the error, so a little more information, or pretty much a lot of information, when you just print the stack trace of e. All right, so we can see that the output here will be an arithmetic exception catch, and then we have the code after the try catch. So we can also have nested try catch blocks, and that is sometimes required, but the requirement of nested try catch blocks arises when a block of code generates an exception, and within that block another code statement also generates an exception. So that is the exception inception, so to speak. All right, syntax of nested try blocks. Let's look at this. So we have a try code block, and then we have another try code block, and then we have the catch block for the first try, and then some exception code that we have, and then we have another exception that we catch. So as you can see, the try has to be followed by a catch, but when you have a try inside of a try, that try has to be followed by a catch. Okay, so these two are connected with each other, and this try here is connected to that catch down there. All right, so this is an example for that. Then we have the finally block, and you saw the keyword finally before. And the finally block is such a block which is always executed whether exception is handled or not. So it is used to execute important code statements. For example, as I said earlier, code that should be run when all of the other code is done, for example, closing the connection. Okay, so we have this function main here where we try to divide 10 by 5 and then we print the data. So our catch that we have here is a null pointer exception catch. So we have this exception that we pointed here because data could be empty, for example. And then we have this finally block here, which always executes. And then we have print line below code just to see what's executed. And if we run this code, we will see that 2, then finally block always executes, and below code are printed onto our console. And that has to do with, first of all, 10 divided by 5 is 2. So this print statement is printed. Then here you see we print the E, so the null pointer exception. So if that would arise, we would print the whole exception. And then we have this finally block, which is executed no matter if try is running without an error or if it's run with an error. So the catch block will be run as well. So either way, we run our finally, so our print finally block always is executed, and of course our below code is also executed. Then we have this throw keyword, and the throw keyword is used to throw an explicit exception. It is used to throw a custom exception. For example, to throw an exception object, we will use the throw exception. So the syntax of the throw keyword is throw some exception. And let's have a look at this. So we have this func main where we use this validate function and we add a value of 15 in there, or we pass a value of 15, and we print some code after the validation check, or pretty much after the validate function. So in the validate function, we check if the age is below 18, and if that's the case, then we throw an arithmetic exception where we say under age. And if the age is not under 18, then we say eligible for drive. So this is not the case for the US, but it's the case for many other countries where you have to be 18 in order to drive. So the output here is exception in thread main java.lang.arithmetic exception under age. So after the colon comes whatever we have entered in those brackets. Okay, so in our case, under age. So this is something that comes in handy when you actually want to make sure that you check your code correctly. And yeah, you just want to throw these kind of errors in order to break your code, in order to understand where the problems arise. So in this case, it wouldn't make sense because it's a dumb example, so to speak, but in real life, it would make a lot more sense when you, for example, need to check your app for potential incorrect entries that users can make, or for potential problems that arise when you get data from the web and stuff like that. And you don't want to publish the app with a lot of throw statements or a lot of errors, okay? Because a throw statement actually makes your app crash. All right, now let's get back to coding. This was a super long example of the whole concepts of try and catch blocks, but now you know pretty much everything about it and we can use it in our code. And all of this might look a little intimidating, but it will really become your second nature once you use it and you see what the advantages of all of those things are. So I'd say let's get back to coding and see you in the next video.